The assumption stack is empty. The constraint list is full. Let's close the loop. Over these 7 chapters, we developed an overview of distributed systems through the systematic relaxation of 7 idealizing assumptions and the corresponding introduction of 7 real-world constraints. The framework's purpose was to make explicit why the field's central mechanisms and trade-offs exist as necessary responses to specific, named constraints, rather than presenting them as an unordered catalog of techniques. Here is the journey, in brief. Chapter 1 Processes address the anomalies introduced once operations on a single node are no longer instantaneous, and the mechanisms, locking, and multi-version concurrency control, and the isolation levels used to control them. Chapter 2 Storage address the cost asymmetry between memory and disk, and the data structures, data models, and caching strategies used to arrange data efficiently across physical storage. Chapter 3 Data address data volumes exceeding a single machine's capacity and the partitioning strategies used to distribute data horizontally. Chapter 4 Throughput addressed read and write throughput exceeding a single machine's capacity and the replication strategies single leader, multi-leader, and leaderless used to distribute load. Chapter 5 Network addressed variable, non-zero network latency and finite bandwidth, along with the communication protocols and anti-entropy mechanisms used to manage them. Chapter 6 Clocks address the absence of a synchronized global clock and the logical and vector clock mechanisms used to reason about event ordering despite clock skew. And Chapter 7 Failures addressed node crashes and network partitions and the atomicity, isolation, leader election, and consensus mechanisms used to tolerate them. It's worth being honest about the framework's scope. Measured against the classic fallacies of distributed computing, the stack we developed here covers network reliability, latency, bandwidth, and the cost of transport block to some extent directly. And it adds storage, scale, and clock dimensions that the fallacies do not name at all. But it leaves network security, topology change, administrative domain, and hardware heterogeneity out of scope, since those are organizational, economic, and security constraints rather than purely technical ones. Across these 7 chapters, the discussion touched on a wide set of interacting system guarantees, among them atomicity, isolation, durability, consistency, availability, latency, scalability, and reliability, and at each stage, the inherent trade-offs between them. And notice one deliberate feature of how we did this. Earlier chapters presented solutions that were only correct under simplifying assumptions still in force at that point in the narrative. The reliance on last right wins conflict resolution in Chapter 4 is the clearest example, correct only so long as a synchronized global clock is assumed. Later chapters then revisited those same solutions once the relevant assumption was relaxed, producing a more complete and realistic picture. That progression is intended to help you approach distributed system design as a form of qualitative constraint optimization, a discipline of identifying which assumptions no longer hold for a given problem, and then reasoning systematically about the trade-offs that follow, rather than as a fixed body of facts to memorize. The ordering itself was a pedagogical device as much as a technical one, and the breadth of mechanisms surveyed here is intended to equip you with a systematic toolkit for decomposing and reasoning through distributed system design problems of your own. If you'd like to go deeper on any individual topic, I'd recommend the following sources. For books, Martin Kleppmann's Designing Data-Intensive Applications and Alex Petrov's Database Internals, both from O'Reilly. Those two are the spine of this material. For courses, Distributed Systems in Practice from O'Reilly and Distributed Systems for Practitioners along with deep dive into the internals of the database, both from Educative. And for video, the Byte Go channel, God of Sense channel, Jordan Has No Life, and System Design Interview. Use video for intuition and books for rigor, and bring the assumption stack with you when you read them, so that you always know which assumptions are in force in whatever you're reading. That brings us to the end of the course. We started with an impossible machine, infinitely fast, infinitely large, perfectly synchronized, and immortal. And then, one at a time, we took each of those comforts away. Processes acquired a duration. Storage acquired a price list. So, the dataset outgrew the machine. The load outgrew the machine. The network acquired distance and loss. Time became relative. And finally, everything became capable of failing. Every mechanism we met along the way, the write head log, B plus trees and LSM trees, partitioning and consistent hashing, the tree replication architectures, quorums, CRDTS, gossip, Merkle trees, Lamport and vector clocks, version vectors, two-phase commit, fencing tokens, Paxos and Raft, total order broadcast, and state machine replication arrived as the forced answer to a specific named constraint, and not one of them was free. That's the mental model I'd like you to take with you. When you face a system design problem of your own, ask which assumptions no longer hold, and then reason forward from there. Thank you very much for watching. If you have any questions or feedback, feel free to reach out to me via email or connect with me on LinkedIn. The links are available in the description below. If you found this tutorial helpful, please like, share, and subscribe to the channel for more such technical deep dives and crash courses. Thank you.